Yes, hello there, and this is Koiro with my third video in the C-64 Power Supply series. And yeah, I've been kind of postponing this video for two reasons. One is that it's very few views on my last episodes, and I think that's strange. Maybe it has something to do with algorithms, and maybe it's that I'm really stink at making content, but the concept of the C-64 power supply is something that everyone has an opinion on. So I was thinking that this would be a popular topic, and especially see I go into depth and explains how this is working and what the potentials are. But enough of that. This is the third part. I'm actually going to make a fourth part to give you some thoughts about why you should not throw away the white power bricks either. This episode is about transforming the beige power brick into a very good transformer that is going to serve your C-64 very well. And I did put out a sidetracked video where I was making this device here with this power potentiometers that I'm going to use as a load. And I've put this now in a box, and this is the final result. It's actually going to be this way, and it's I have this 5 ohm, 10 ohm, 100 ohms and 500 ohms to be able to use this for more than just this application. And I'm going to load this with the 5 ohm on the 5 volt and this 10 ohm on the 10 volt and make some maximum power draw on the power supply according to the specifications on the power supply, and I'm going to exceed these expectation by quite a bit, and we are going to see that the power supply actually will be up to the task to deliver what we want. And if you want to see more of this kind of builds, this is something that I did out in my shed. It's just a sheet of aluminium painted racing green and made some holes and stuff. And I also put on the big wheels here because the small ones that actually was supplied is these small knobs here, and they was not really up to the task to get some good grips on these potentiometers. It's not very high quality potentiometers, but let's hope they are doing the job. And if they are going to burn, we are going to see this in this episode, because I have not done the tests yet. So this will be the first time this is used, is when we are going to test the finished C-64 power brick. So that will be the topic of today. We are going to modernize foot warmer, aka the C-64 European power brick, and this content is also valid for American users. The regulator and the stuff is the same, so it will be quite a good content. And this is not breaking news. There are people that has done this before, but they have not done the throughout background and measurements and stuff. So we have to cover some theory before we go to the bench. And this is the part here where I try to explain why a switch mode power supply is more efficient than a serious power supply. Not serious, but serial or linear power supply, of course. Yes, here you go. Yes, and today's topic is to, we have dealt with understanding how the power supply works and what it does in its original form. Today we are going to see and look into what we can actually do with this power supply to make it a modern, useful device. And to do that, we have to do a bit of mansplaining first to understand how a switch mode power supply actually works. And I've tried to explain this many times, and I do think that I've gotten better to it, but I do know that some of you will still be confused, and it's not a very easy concept to grasp, but I will try. And please leave a comment if you think I've got something wrong or if I have simplified this too much. But today's journey is the whole way from the AC power line to the transformer that's inside here, and making a regulator that can supply both the 10 volt AC. It's 9 volt, but we know that this brick produces about 10 volt, so it's going to be 10 volt, and the 5 volt DC that is needed down here. So it's actually the whole powertrain that we are going to look into today, and we are going to make this a safe device so that you can use it on your C64 without any concern for anything going bad and supplying your C64 with high voltage. And let's start with the internals, how things are done inside this power supply. And we have measured on this many times, and we do have about, if you take it like this, it's about 28 volt peak to peak, and it's about 14 volt then up here. And if you take the voltage of these, you take the 14 volt something and you divide it with the square root of 2 to get the voltage, and that is about 10 volt. It's some inaccuracies here, and it's not about the details and the decimals, it's about the principles for this. And this is rectified through this rectifying bridge, and also we do have some slightly different approaches to do this, but this is what we show here, and this is actually what's in the power brick we are trying to modify this time. And that means that the voltage we got here is about 1.21 volt something lower than the actual voltage supplied, and that is just fine. We do have a lot of voltage to take care of, so even if this is about 1 volt with maximum power draw, it's something we don't concern or with in this principle. And we do use a capacitor, and we are straightening this out. And this capacitor will charge during this period, and here it will discharge. And how much this will discharge, it depends on the power draw. If you have large power draw, it will discharge like this, and you will have a larger ripple. If you don't have any power draw at all, it will be almost straight line like so. So this is depending on the discharge voltage of this capacitor. And there is a formula to describe how much ripple you are going to get with frequency, capacitor size and power draw. We are not going into that here. But the resulting effect will be something like this. And this is 100 Hertz because we are doing this rectifying, so each of this will repeat itself each time you have a zero down here. So that means that you have 100 Hertz ripple here, like so. And that you are putting into this voltage regulator, and you are getting 5 volt out. And this is the way everything works, but this voltage regulator here is what we are going to look into today. And this is an extremely theoretical approach, and it's not working circuits we are talking about here. This is what we had before. This is the old solution. This is the serial liner regulator, where you have a voltage in, you have a voltage drop, and you have a voltage out. It's Kirchhoff's law that you have to sum up all the currents or all the voltage drop in a circuit, and that will all add up. So you have V out is V in minus V drop. And the loss in this circuit is the voltage drop times the current load on the circuit. That is the loss you will have here. And this loss occurs because we do have a voltage drop over the regulator. And a voltage drop is because there is a current running through this regulator all the time. So even though you do have lots of spare potential for driving current here, the voltage regulator is always connected and it's always drawing a current through the load. The switch mode power supply is actually based on switching in and out the load. So that means that the load is not connected to the circuit, or the load is not connected to the main circuit all the time. So what we are doing here is that we are switching off the voltage when we are not using the current, and we store some capacity here in this capacitor that you can use to supply the circuit when the switch is off. And of course this is greatly simplified. You don't almost just have a capacitor here, you do have some kind of coil or something here that stores the voltage and takes it the other way, and you have a diode and so on. But this is an extremely basic principle. If we have 10 volts and we have a current of 1 amps, we can actually switch off the power half of the time if we want this to be 5 volts. This is extremely simplified, as I said. So if you take and switch on and switch off the supplied current, you will have a loss over this switch that is 0, because when this switch is open, there is not going to be a current. So the only current drawn from the source will be when this switch is closed and the load is connected. That's the basic principle of a switch mode regulator. And then you are regulating with frequencies and phase mode and stuff to make sure that this is regulated good enough. But in its most basic form, this is what switch mode really is. And you can see here we have tried, this is the same as we had on the last page. You can see here that we are actually switching out the voltage here, and you get a new AC voltage that is the frequency of this switching and not the frequency of the line. And this has a duty cycle of about 50, because we have about 10 volts and we need to have about 5 volts. So when you can see, when we are actually smoothing out this voltage here, we take this top here and this top here and this top here and this top here, and we use that power down here instead when it's turned off. So this is actually used here, and this is used here, and this is used here and used here, so on. So the area under the curve is the load power draw. And this is, of course, in an ideal world. Of course, you don't have 100% switching off. You do have some losses. You are not switching this in a perfect square. You use some power to regulate. You use some power to run the circuit, and so on. But basically, we are just keeping the load switched off from the power source, and we are supplying the current that is left over on top of these curves here. And we do have some modern circuits that does this much better than my explaining will do. And we are going to test at least one of these, and I do think we are going to use this first. This is very simple and it's very easy to solder in on my board. And it's actually dimensioned for supplying. Some say that this is supposed to deliver 5 amps. Some say that is 4 amps. You can see here they have 4 amps, they have 5 volt amps. But the reality for this with the components used is this will be good for about 2.8 amps something. It will at least be good enough for what we are doing here. And this has a switching frequency of 500 kilohertz, and it can take an input voltage from between 5 to 20 volts, so it will be perfect. And it have a working temperature up to 85 degrees Celsius. And it's a very small size module, so it will fit quite easily. And I also have this one. This is a much sturdier device. It's regulated, so you just regulate this into the voltage you want, and you keep this closed. And it has a bit lower efficiency than the older devices. They say that this is 96, but here they state 99, and the truth is not always there. But let's say that we have about 93-92% efficiency, and that should really give us the voltages and the currents we need and are able to draw from our brick anyway. So that is today's mission. We are going to replace some of the internals with this regulator board here, and if you're not going to get the satisfying results, we are going to test this board instead. So let's get to it on the bench. Yes, we are now back at the bench, and we are going to just modify this print. I have seen a lot and lots of inwards of these power bricks, but I think it's the first time I see this exact model. And I'm going to desolder the capacitors, and I'm going to solder in this PCB. And I do think that the ground is common for both sides. I can just measure out that. Yeah, 0 ohms for the ground. And of course this is very high ohm, yes. So I'm going to drill some holes in this PCB, and I'm going to reuse this PCB. And this is a 4700 microfarad capacitor, and I'm going to replace this with this two 3300 microfarad. Yeah, they are low ESR, and they are 105 volt. Not 105 volt, but 105 degrees Celsius maximum operating temperature. And these are going to put more strain on the rectifier bridge, because this has to be charged through this bridge, and that is quite the high startup current. But let's hope that this bridge survives. It should do that according to the datasheet. But there is no way to know, and I'm not going to change that as of now. And I'm just going to desolder these components. This was fully working, but it's very old. And the same with this capacitor here, that I really don't know what are. And if this is just a ceramic transistor capacitor, it would probably last forever too, but I'm not sure. See if there are some writing on this. I do think this is a tantalum, because it's, I'm not sure. It's marked with a plus, so I do think this is a tantalum. And I'm going just to replace it with this 100 nanofarad ceramic capacitor to take some noise off the line. Yes, just like so. And my minty green cutters, like so. And this I'm going to keep, and I need to drill some holes. This I can place, I can drill the holes just like so, and I can raise this one from here. This is the ground wire, and this is the 5 volt. So if I drill a hole over here, I can just place it like so. Yeah, I will do that. And this regulator, you do have the output lines here, like so, and you do have the input here, and this is going to be bent away, and I'm not going to use them. But the regulator is so that it's ground here and it's output here. So if I just drill some holes and just place it, yeah, like so, and I will just mix the wires in place. So I will go out and drill some holes. And where do I go? Where do I drill these holes? I have to see if I can get some markings. I do have to drill a hole about here for this capacitor, and I will need to drill a hole here for this other capacitor. And for this one I do have a hole here for the ground level, and I do need one for the input and one for the output. And if I put then all this up to the light, yeah, I think that will be it. I will drill one hole here, one hole here, or I might put this capacitor on its side here. Then I have to make the ground. Yeah, I might place it just like when it's going outside. No, I'm just going to raise it. It does not matter because there is plenty of space here. Yes, I will go and drill those holes, about 1 millimeter holes. Yeah, and we are back from the shed and I have drilled these holes, just 1 millimeter holes. And we do have this one with input, output. Wonder if I just use these ones. These are just some cut off legs from an LED. I bent them like a hook shape here to be able to solder like so, and see if this design will work. I've put them the other way around to have some weight on this when I solder here. Yeah, and the really sharp aids among you will see that here I do a huge mistake that I will have to correct later. Like so, and now I have not measured the size and the width between the legs, but I do have the output here, so the output has to point this way and the input the other way. So it will be something like so. And I can, of course, I can bend the legs like so, I think. Yeah, and I need the ground connection from there to there. And I must check that this fits inside here. It kind of does not. I have to move it a bit closer to that one. Sorry for that. So then I just reheat the solder and make the chip a bit further away from the PCB, and I just push it in place. Yeah, and now it fits perfectly. Yeah, and these legs of the power regulator, this power regulator is still good, so I don't want to destroy anything inside this power supply if I don't have to. So I just push these legs away, and then it will be like so. And then I need some capacitors, and this one, it has the minus this way, and I'm going to put it like so. I do think that will fit, because this has this, so that will fit. So just solder this in. Probably I won't need any more than this capacitor, but just to make sure that I have enough, and maybe to destroy the work here, I will put this one in, and it will have the plus wire this way and the minus the other way. So I will just take it like so. Yeah, it will be a bit difficult to place this like so. It will be quite a narrow space here, I can put it this way, of course, and this will be the minus lead. Then of course it should have been the other way around, that the short lead that is uninsulated should have been the ground wire, but I just connect it. Yeah, when we are doing ugly, we are doing ugly, so that's quite good. Yeah, and I might do some more holes. Maybe I should put a diode here to see if things are on. I'm not going to drill into this case, but if I place one diode against the grills here, I do think it will light up the right way. And I do have some holes left here. I do have the ground hole that is over here by this capacitor that I can use, and I do have a hole in the ground also here, and I do have here on the plus line, I do also have a hole. So I just need to hook up this this diode. This is the plus and the minus, like so, with a resistor in between. And if I'm going to place this, it will be against the edge of the power supply. So I'm just going to find a suitable resistor for this. Yeah, and this is me adding in the diode that only is going to serve the purpose of showing me that the 5 volt is working as it should. I'm going to use some existing holes to solder this in, so it will be a mix-up, but this is a series resistor that is connected to the ground, and the top of the circuit is connected to the anode of the LED. So it's quite the easy circuit. And this will just spread the light out through the ribs on the side of the power supply. And some of you might be screaming, but this makes the power supply less efficient. Yes, it does, but this is only about 9 milliamps we are talking about here, so it's no big deal at all. And is something this power supply should have had from the get-go. Yeah, double check. This is out. This is out. Yeah, I have to solder the ground wire, and then we should be good to just put this in. I think this wire is 0.75 or something. That should be it for this, and it will be a bit long, but yeah, we might be able to fit this one. It did fit in this one. Oh, sorry, my bad. You can see my mistake here. I used the minus here, not the plus. So I have to desolder this whole module again. I solder the ground wire to the PCB first, then I take this out and turn it around. Very good thing that I noticed until it was too late. Yeah, after some quick desoldering and soldering on new legs, we are ready to get going again. That is the input side of things, and that is the output. So input and output, and we need to put this as close as we can to this rectifier bridge. Yeah, then it's the plus and plus and plus in, and it's plus out. And then I need the earth wire, and I did have the earth wire ready here. I think that went quite good. It's just one single thread of copper, I think, and that I can bend around. So then I have connected up the power regulator. I have connected up this diode. Let's hope it has the right polarity. And I connected up these capacitors. And if I'm going to place this here, like so, you can see here that I'm not touching, I'm a bit touching into this this aluminium, but this is one winding that goes to the rectifier bridge. Just solder down, and one winding, and I have this lead here and this lead here, and we should be good to go. I of course has to cut this one and this one. Just like so. And here I need a bit of solder. Like so. Yes, then this should be pluggable. I do intend just to plug it in live and see how it goes, but I need to connect some means of making measurements. I do have the power cord here, and here I do have my C64 power connector plug, and this was the +5 and this was the AC. So I'm just going to connect up the fluke volt and just make some good power choices here. This is the common, this is the voltage, red, 5 volts, and connected like so. I turn this way here so that I can see if the LED is turning on, and I will be able just to plug in the power cord. And the LED is lighting up. You can see it here through the power brick, and it's 5.116 volt. So this is now working, and I also can measure up the AC voltage from these other plugs here. I do think I will be able to, without I can of course unplug here, and yeah, I do have to do that. Now this is like so, 10.89 volt. So now my power bridge is connected, and I can try to put this up to some load and see how things go. This AC winding is not of so great concern as of now, because we have tested that to the limit and to the maximum, and it did not show any sign of weakness. But of course now we have connected a whole new power rail on this one, and I'm just going to hook it up to the resistor. And I'm first going just to hook it up to the, here is my resistor board. I'm going to make like so everything will fit inside the picture. And this is the 5 ohm resistor. If I connect 5 volt to 5 ohm, I will have about 1 amp. But I will first try to connect it just straight over here. Then I will have about a half amp on this. And I can check the voltage again. Now it's the DC voltage. It's dropped to 4.94 volt. That's not so good. And I can check, I can just disconnect here and check how much this resistor is. I can of course have missed something when I did the mounting here. No, it's about 10 ohms. and 10 ohms into 5 volt. Yeah, it's 5 volt in 10 ohms. So this current is about a half amp. You're not getting any temperature yet on this one, but I will try to step this up and have 1 amp. And it's the Ohm's law. If you have 5 ohms on 5 volt, you get 1 amp. And I'm first going to check with the ohm meter what I do have here, 5.0 about. And now we have connected this and running 1 amp through this, and it's down to 4.84 volts. It's not very good for our regulator, and I do think that we do have some loss, of course, in the leads, but I don't think it's that much. But that we can check, because we do have our output down here, just to be, yeah, it's 509, so we are losing something in the connections here. It's not the best of plugs, of course, and we do have this plug down here, of course, also, so we are losing some in the connection. So the regulator is doing just fine. It's supplying 5.9 volt, 0.9 volt, 5.1. And now it's running with 1 amp, no problems at all. But we are going to up the game, and we are going to drive 2 amps from this power supply. I'm going to turn it the other way around again, so I'm not missing anything into it. And it's cold as ice. And I'm going to now turn the knobs so that I get about 2.5 ohms into this one. Yes, 2.5 ohms, and that should give us 2 amps of load when I connect this. And of course now it's the center of the potentiometer, and now we are really trying this for some time, because now we are running 2 amps into this, so it's about, yeah, maybe 10 watts that is drained here. And if I measure the voltage now, yeah, it's 4.56 volts that will reach our C-64, or maybe not, and I can check the output down here, 4.79. so this is, it's running just fine, and now I'm drawing 2 amps of this power supply. And in addition to that, I'm going to take 2 other leads. This was maybe a bit thin, but I do think it will hold up. I'm going to try to, might avoid blowing the fuse, but if I connect this up like so, then I'm loading this power supply with 1 amp on the AC rail and 2 amps on the DC rail. And is it getting hot? Not so much. And I can still see the red LED light inside here, so I know the fuse is not blown. I can of course measure now the AC output voltage. Yeah, and 9.87 is way above spec still. This should be 9 volt, but 10 volt of course works quite okay inside the C-64. I loaded this with 2 amps. You can load this with 1 more amp without killing anything. You might blow the fuse, because the power draw is not meant to be more than 3 amps in total on this one. So that's it for the work on the bench today. Yeah, this video is not showing all the stuff I done to measure this power supply here, but I can assure you it did stand the test just fine. And I did measure some ripple and some noise, and what you can see here, As you can see here on this picture here, this is from my scope, and there are some noise. It's not very consistent, but this is with very high load. This is measured with 3 amp load on the 5 volt output. And I do have some millivolt with noise and quite a high frequency on the noise. This regulator should switch on 500 kilohertz, but this noise I'm seeing here is about 45 kilohertz or something. So there should have been a noise capacitor here, but you know what? That is already inside your C64. There you have the caps and the stuff that will filter this out just fine. And when I load this with 3 amp on the 5 volt rail and 1 amp on the AC rail, it's not getting hot to the touch. I can feel that it's not warm, but it's lukewarm. And I can probably draw more out of this, but of course the fuse will put its limits. And the fuse on this one is on the input side. We don't have a fuse on the output side of this. There is a fuse in the C64, of course. By the way, these white specks on this scope, it is dust. It's kind of rude of you to notice. And I should have cleaned off the screen before I did the measurements. Anyway, this has been a long series, but we're not finished yet. Because we did run into a problem. Oh, sorry. When we was trying to get the lid out of these power bricks. And this is by far the most common power bricks that are left. Because a lot of guys is telling you to toss these away. You should not do that. This is quite a valuable power supply, and this modification I've done here today, it's less than 100 krona with the capacitors, the LED and the regulator. And if you're gonna go cheap on this, you can go AliExpress, buy the capacitors, buy a new rectifier bridge, buy the regulator and everything of this for less than $5 bucks or 50 Norwegian kroner. It costs next to nothing to fix this power supply. It's quite stupid to toss them away. The plug and the power cord on your new power supply cost more than it costs to fix this one. So don't toss these away. They are valuable and they need to be fixed, not thrown away. But these ones, I'm going to show you a method that will keep your C64 healthy, and this is not the C64 Power Saver that is just disconnecting your C64 if anything goes wrong. No, but you can, in my case, I'm going to fix it so that you can still continue to use your C64 even though the power supply breaks. So that will be the 4th episode, and how long it will take I'm not sure, but I do have a lot of commitments the next couple of weeks, so it might not be until June before this is released. So sorry for that, but in the meantime go back and watch some of my older videos. I would be quite happy for that, even though if you put them on just to fall asleep quite easily, because I need the views to get up my hits and to make the algorithm work on YouTube. Now I'm on a self empowered, or what should I say, powered downward spiral, where my videos is getting less and less hits, and that is because I only have about 2,600 something hours of view time the last year. And if you guys can make this hit the 4,000 mark, I will get in on the lowest level with YouTube, and I will get more hits due to the algorithm. As now I'm flying under the radar everywhere. But you need to spread the word. These should not go into the recycle bin. They should be remade. So, thanks for watching. Hope to see you again in my next episode. I hope you have learned something. Hope I have been able to help you save some of your C64 power bricks. And if not, you have learned a lot of stuff about power supply that you never wanted to know in the first place. So, thank you. Please go and watch some of my older videos and see you the next time. Thanks for watching.